Hi guys, we are continuing with organic chemistry and today we are going to be looking at isomers. Okay, so what is an isomer? This is a whole different or new term for you guys. In isomers, the same atoms are used in different compounds, but they are assembled or connected in different ways. So in other words, the compounds look different. Now, there are different kinds of isomers in organic chemistry. So we are going to be looking at three different types of isomers, namely chain isomers, positional isomers, and functional isomers. So isomers are compounds with the same molecular formula. This is very important, this definition, but it has different structural formulas. So in other words, like we said earlier, it has the same number of atoms and the same types of atoms, but it looks different. It has a different structural formula. So first up we have our chain isomers. So you can see here that I gave you two different organic molecules. Each of them has the same molecular formula, C4H10, C4H10, but they look different. So you see they have the same atoms, the same number of atoms of the different elements, but they are arranged in a different chain. That's why we call them chain isomers. So this one, for example, is butane, but this one is 1-methylpropane. So that is an example of a chain isomer. It's just branched differently. So remember, when they ask you about isomers, they are going to give you one example. So they're going to give you an example of butane, and then they're going to ask you to either give the IUPAC name or the structural formula of its chain isomer. So you will then have to draw your own molecule, but it's fine. Just remember to draw the same number of carbons. So if this one has 4 carbons, you also draw 4 carbons, and then you just fill in the blanks with your hydrogens, and you'll see it all works out that they both have the same number. So your chain isomers normally occur in your alkanes. This is the homologous series that we use for our that we get chain isomers. Up next we have our positional isomers. So positional isomers are isomers or molecules that are in the same homologous series, but the position of their functional group is different. So for example, let's take an alcohol like butane 1-ol. Here the OH group is at the end of the chain, but over here the OH group is on carbon number 2. So exactly the same. It has, as the previous one, it has the same molecular formula, but it has a different structural formula. So just remember, when they ask you, say for example they give you butane 1-ol and they ask you to draw the structural formula of its isomer, its positional isomer, remember it's very important where you place that OH group, because you have to place it either here or there, because if you place it on carbon number 4, it's actually the same molecule, it's just the mirror image. It was just rotated or reflected in a different way. And when I give the IUPAC name for it, if the OH is here, it will again be butane 1-ol, because we will number our chain from this carbon instead of this carbon. So just make sure that it's not just a reflection of the previous molecule they gave you. Exactly like with butane 2-ol, I can't put that OH group, if they give him here, you can't put him there, because if you give the IUPAC name, we will number from this side, and it will again land on carbon number 2, so it will be butane 2-ol again. So this is actually a quick way to check if you drew the correct positional isomer, is if you give the name of if the name of the organic molecule they gave you and the isomer that you drew is the same, then you know it's not an isomer, it's actually the same molecule. You just drew it differently, with differently, it's reflected or something like that. Okay. And these normally occur with something in something that has a distinct functional group that can change positions. So it will be your alkenes, alkynes, haloalkanes, your esters can have that, your ketones. But two examples that, or three examples actually, that can't have positional isomers, my alkanes. So let's just make an X over here to say that it can't. Also, because it doesn't have a specific functional group, like a specific bond or a specific atom that has to be somewhere in the chain. So they just occur, they just have chain isomers, no positional isomers. Next up, we have our aldehydes. They can't have a positional isomer because their functional group, as we saw in the introduction, the previous video, the the O double bond has to be at the end of the chain, so you can't put it in a different place. And if it's like butane 1, or if whether it's here or here, it's the same molecule. So this one doesn't have a positional isomer, and the last one that who doesn't have is a carboxylic acid. Again, it's because the functional group has to be at the end of the chain. Now, lastly, we're going to look at functional isomers. So your functional isomers are isomers or molecules that are in different homologous series. So they have different functional groups. So luckily we only have two examples. So here I gave you the one example. Again, sorry, this textbook has it wrong. This one is an aldehyde because the carbon oxygen double bond, it's at the end of the chain. So this is the one example. We have the ketones and aldehydes. They are always functional isomers. And the other example is carboxylic acids and my esters. So they always have the same molecular formula, but they are actually in different families. So, for example, if they give you the ketone, like here, and they ask you to draw its functional isomer, you know you're going to draw an aldehyde with the same number of carbon atoms. So you look at this one, they gave you 4 carbon atoms, so you just draw one that also has 4 carbon atoms with its functional group, and then you just fill in your hydrogens, and you'll see that it matches in the end when I write out the molecular formula. And the same, if they give you an ester, you draw on carboxylic acid with the same number of carbon atoms, and vice versa. So that's isomers, everything you need to know. They will ask you this in question 2 of your exam paper, so know the definition of an isomer, and you should also be able to, if they give you one molecule, either draw the chain, positional, or functional isomer of that molecule. I hope this video helped you. If you liked it, give it a thumbs up please, and subscribe to the channel for more videos.